Hello, welcome back once again. My name is Samuel Ambrose Oneng, your tutor for a computational model for solving problems. I have come up with this model, as I said previously, just to demonstrate how algorithm works and how algorithm can be designed, and that is the core of the working behavior of the computer system. So what I am showing you is what really happens inside the processor itself when the processor is actually processing some kind of information. For example, when you input data in the system, the arithmetic control unit will receive the data from you and then inform the logical control unit that, hey, you know what, I've got some data. The letter line up, and then it passes the information to the memory somewhere within the processor. And then arithmetic logical unit will now fetch the information from memory, process that information. After finished processing, it puts it back in the memory and go to the control unit and ask the control unit, hey, you know what? I've just finished with that information you gave me. What next? The process carries on like that until when everything is done, then the output will be given to the user. So that is how processor work. But computational problem happens actually during that processing time. you know at the point of processing, that's where we get the computational problem. Remember when I was talking about the model for this computation, I came up with this model. The model itself was A times nu equals to B. That was the beginning for everything, where A was modeled as a problem and nu was modeled as the solution to the problem, and B is the expected output. Just like when you're designing a software system or when a stakeholder comes to you, wanting to kind of like, solve some kind of problems. Remember, all the stakeholders, all the business owners, yeah, talk about like maybe Google, talk about Amazon, talk about Facebook, talk about those big giant company. Don't think they did not know what they wanted. They wanted something, and that thing that they want is B. Just like in other small business, when you are running or starting a small business, you may expect something, and that expectation is basically what you want to do and why. What do you want and why do you want? And most businesses have the objective of making money, nothing else. They want to make money. So that's what they want. Why do they want to make money? Maybe because they want to be rich, they want to help people, they want to help their families. There could be many reasons as to why they want to make money. So what they want will be this expected output B, because they want to make money. And the reason why they want to make money is well known to them. So when they're solving some problem, they may want to do something in order for them to make that money. And that, my friend, is where A comes in. A is that problem in the world that they want to do in order to get nu, which is the solution, so that they can arrive into B to get money. I'm just thinking in computer perspective now, you see, and the application of this model and implementation. Now, what they want to do and how they want to do it is what this computational process is all about. Remember, in the computer, we talk about how to solve the problem, and that is algorithm itself. Algorithm is about how can we do it? How can we make money? B, we want to get B, but how can we get there? So most businesses want to make money, but how can they get there? And where they need how, that is where algorithm is necessary. This is where algorithm plays a great role. What they want and why they want it, that is what business owners are well versed with. They know what they want. They know why they want it, but they don't know how to get there. And how to get there, my friend, that is where algorithm becomes meaningful. So, in a previous video, we proved the concept. We came up with a small problem, and we say that the problem exists in a three-dimensional space, and we came up with the solution of the problem as well. And in this video, we are going to further explore the problem that we came up with and the solution that we found to prove this concept further, to show that in reality, do we really have the solution to the problem, and where does the solution lie if the problem exists? Now, as I've just said, the solution lies somewhere within the space, and the problem also exists within the same space. So X and Y and Z could be used as the axis, to let us know the direction of the problem, or where the problems are escalating. Where are they going? How are they increasing? How big are they? Can we solve them? So as I've shown you previously, this is just a three-dimensional problem, and I pointed out somewhere that this dimension A1, A2 going to A3 symbolizes or represent the complexity of the problem. As we go from one dimension to another, the complexity of the problem increases, and the complexity of algorithm also increases with time and space. So that is what we are going to see now. How does the scaling up of the problem affect the algorithm complexity optimization? How can we optimize those kind of problems? Well, this is something that I know many of you might have learned about algorithm, about complexity optimization, and they focus only on time. But it is not only the time that we need in order to analyze the algorithm complexity. We need to know about the resources that are needed for the system to solve that problem. We need to know about the tools required, the programming tools that we need, the memory size, the capability of the operating systems, and of course, time will be there and space. So those are the factors that will directly affect the functionality of algorithm, leading to either low complexity or high complexity optimization. So the problem can be solved within a short period of time if it is less complex. But if it is heavily complex, it will take time, it will take more resources, it will take more space, it will need many tools for it to accomplish its task. And that, my friend, is all about algorithm complexity optimization. So I'm going to show you how the problems scale up and what steps will be required to solve the problems which are increasing. Of course, the more the problems, the more the steps, and the more the resources we need, as well as the time and space to solve that algorithmic problems. So thank you for viewing. I will see you in the next video. I just wanted to demonstrate this thing and to give you a brief introduction to the complexity optimization of algorithm. I'll see you in the next video. My name is once again Samuel Ambrose Onen, a BSc MSc holder of advanced computer science and a reader of mathematics and computer science, of course, from one of the most prestigious, well-known university in the world. I'm proud of them because they made me who I am today. So I hope you will enjoy my course. Thank you.